Okay, hi, my name is Salinas. I'm a NOAA CCNE scholar from the University of Texas Rio Grande Valley. As Dr. Sintra mentioned, I'm going to be talking about my thesis and kind of my natural project. I was able to bring those both together. And it's on the growth and reproduction of antipatharians in the Gulf of Mexico and in an aquaculture aquarium.
Turn on the button. Oh, it goes to sleep.
Yeah, it goes really fast.
Is it working?
It's working here, but not there. Yeah.
Okay.
It's changing here, but not there.
It's delayed, so it will turn back.
The images are much clearer up there, it's not changing.
When it's just a projector. Nope. I'll do it manually.
But is it even changing here?
No.
No, it's not
No,
changing.
it's not even if you do it manually.
Maybe it's another.
I think you have to do the.
You go to display settings. There.
It's like
It's
not
hidden- it's
here.
hidden here.
It's like
so-
not here.
And if we get the mouse in there,
It's they're controlling it. Every session.
With advanced slides.
Oh, there it is. Got it. Yeah, we did. Okay. Sorry. So yes, I'm going to be looking at antipatharians, also known as black corals. They're part of the order Antipatharia and subclass Hexapraelia. So these are the other corals that Dr. Houston didn't talk about. So currently we know of 7 families that are recognized today. They do not have a zooxanthelia within their tissues, unlike your Starotinian corals, which means that they're not restricted to shallow waters. So most of them, about 63% of them actually are found at supported depths or deeper. And however, as Dr. Easton mentioned, we still don't know much about them, and we don't know much about their life history or biology. And one of the important reasons for me going into this project is in the Gulf of Mexico, there is a lot of exploration of hydrocarbon. As mentioned in some other talks, the deep sea horizon oil spill did have a large effect on antipatharians in the Gulf of Mexico. And actually, one of the corals that I'll be talking to you about today was greatly impacted. I think it was in the top 8. So for my objectives, my first objective was to compare growth rates of Antipathes at Atlantica and Stichopathes zucchini at the Texas Clipper Artificial Reef. So the Texas Clipper Artificial Reef, as you can see in that picture, or that map right there, it's located 17 miles offshore of South Padre Island. It was a Navy ship that was sunk for artificial reef purposes. And one of the unique things that this ship gives to the environment is that it has these large compartments that are the majority of the ship. So this is where I find most of my Stichopathes zucchini. So it mimics a perfect mesophotic habitat, even though the ship is only at 130 feet in depth. So my second objective was to determine reproduction frequency and timing. So we wanted to know if they're reproducing more than once a year and what month of the year they're reproducing. So for my methods for gathering growth rates at the Texas Clipper, I used volunteer scuba divers, mostly students. So we would go down, we would select our coral colonies and we would tag them with cattle tags at the base. It's kind of hard to tell with the light, but there is one cattle tag right there, as you can see. The only difficult part about this is they were kind of hard to locate every once in a while, and some of the tags would come up, but we did our best. We were measuring with flexible measuring tape. For Antipathes atlantica, we measured width and height. And for Sticklepathes zucchini, we would carefully extend it to its maximum height and gather its growth rate that way. So to gather growth rates in an aquaculture system started off with building an aquaculture. So unfortunately, I had to do my nurture virtually, so I had to basically build the system myself. So I had a 90-gallon main tank that was connected to a 45-gallon sump. And the sump is basically where all the filtration and heater was located. So for Antipathes atlantica, we gathered about 5 colonies and then I fragmented them from that. There was 15 single branched and 15 multi-branch fragments that varied in sizes. I did this just because I wanted to see if there was any difference in survivability or recovery, or if there was in a difference of their growth rates, if they stayed single or in branched form. For Sticklepathes zucchini, I had 15 fragments. They also varied in sizes for the same reason. We just wanted to see if for any reason they were growing faster, if they were smaller, or if they were larger size. So all fragments were measured every 2 weeks. So I would take each fragment plug out of the rack, bring it up to the surface while maintaining it underwater, and using a flexible ruler in order to get their growth. So for histology procedures, we would go out, weather permitting, seasonally, and we would collect about 6 colony fragments. So we weren't taking large pieces. It was usually between 2 to 5 centimeters. And they were stored in 100% ethanol at -20 freezer. After I had collected all my samples, I manually dissected the polyps off the skeleton with the smallest needle I could find. And this took many stressful hours, but there was no other way. I reached out to a lot of other scientists that were trying this, and this was the only way. So I got 2 polyps off of every fragment. After that, I dehydrated them with a series of ethanol, which involved 50, 75, 95, and 2 series of 100% ethanol. The following day, they were infiltrated in paraffin wax, and these blocks were formed on these histological cassettes. You can kind of see one of the polyps there. So then I used a manual microtome, and there were sections between 3 to 4 micrometers in thickness. It was just, I was just trying to see, eyeballing it to see if I was getting a good cut. And I try to get, 4 to 5 cuts per slide. So once the slides were dried, I stained them in xylene, an ethanol series, DI water, hematoxylate, and eosin. So for my results for Sticklepathes zucchini, when comparing their growth rates to an aquaculture and in tissue, in the aquaculture, they averaged 0.11 centimeters a week, and at the Texas River, 0.73 centimeters a week. So in comparison, we saw no significant difference. However, you can see somewhat of a difference there. And I'll talk kind of the noise that's going on in that. So for Antipathes atlantica, they had a mean average of 0.32 centimeters a week in height and 0.34 centimeters in width. So you can see that there was a gradual growth rate throughout. Just with some minor abrasions. There is a lot of fish, and there is a hot spot for recreational diving, so we kind of needed to put back into that. However, in an aquaculture, we had at 2 months, approximately 2 months, we had a full polyp bailout on all Antipathes, so we did have full mortality on that species. So I didn't have their growth rates in this slide. And then when we compared Antipathes atlantica and Pseudopathes zucchini applicable growth rates at the Texas Clipper, there wasn't no significant difference in between their applicable growth rate when we ran a t-test. So for stages of oogenesis, which are your female polyps, the stages were based off Dr. Parker's research done in 1997, I believe, as well as Dr. Wagner's that was in 2019. So for our female polyps, these are for Sticopathes. In the month of June, we believe that they're at stage 3, which is maturing. So we can see the beginning of oocytes forming. We have a few in this slide here, but they're still a little ununiformed in size. One oocyte. For the month of September, stage 4, we believe that they're at the mature stage. This is where we believe they're either at full size or close to full size right before reproduction. And here you can see they're mostly in a round form and they're more uniform in size. For the month of October, we believe they're at stage 5 or the spent. So this is where we believe they have already released their oocytes into the water column. You can see that most of the mesenterus is pretty empty for the exception of a few straggling oocytes. So for spermatocytes, which are our male polyps, in the month of June, we believe they're at stage 2, maturing, same as our female polyps. So we can see the beginning of a cluster, of some clusters. You can see that the tails are all forming in the same direction within the mesenterus. In September, we believe that they're at stage 3, their mature stage. So this is where they are really packed in that mesenterus. There's very little space of the lumen. You see the bright heads of the spermatozoas. So yes, this is where we believe they are full mature. And for the month of October, we believe they're at stage 4, which is our spent stage. And we can clearly see there's only 2 spermatocytes still left over in the mesenterus compared to our September month. So in conclusion, there was no significant difference between Sticopathes zucchini in an aquaculture or at the Texas Clipper. However, this may be due to measurement bias. It is pretty difficult to extend the length of these Sticopathes zucchini underwater. I try to keep the same divers doing the same job every time, so we can try to remove some of that human error, but that might be one of the reasons. There was no significant difference between applicable growth rates, Sticopathes zucchini, Antipathes atlantica at the Texas Clipper. For Antipathes atlantica, because they do grow out to the sides, we may think that they're growing their width before they're growing height, or they're growing faster to sideways just to increase that surface area to gather prey. And for Sticopathes zucchini, they might be growing faster if they get hit, abrasions, or even getting eaten by other fish. That's silver. So for my histological data, reproduction appears to occur in late summer. In my case, it was in September. I'm still working on, getting those overall stages per month. Usually stage 1 and 2 are the most difficult because they're not as visual. For oocytes diameter, I'll be measuring their diameter to give, a size of when they are about to reproduce and when they have not. And I will be comparing that to water temperatures at the Texas River. Just to point out, we have successfully now grown about 4 colonies of Antipathes. And it is to point out that we did keep their anchor or their hold fast from when removing them from the clipper. And some just observations that might help restoration, just some tips. You don't want to keep Antipathes and Sticopathes too close together. It might be hard to see, but there was some abrasion in tissue. We did observe that Stickopathic zucchini doesn't just grow from one side, it can grow from both sides. So here's the bottom of the rack and the coral is growing downwards. Morphological, they do have polyps only running from one side of their colony. However, this Stickopathic was kind of too close to the glass, so he reoriented his polyps to the other side. So that was really cool. And they also adhere to glass on either side, so you might want to pick up for that. And for Antipatharians atlantica, this is the only picture I had right before full polyp bailout. So they did hold on to their polyps even after losing all their tissue. So it's almost like a survival, like they're holding on to those polyps right before they die, basically, and try to reproduce that way. So acknowledgements, I want to acknowledge my committee members. I have a few, but the ones that are here, Dr. Sintra, Dr. Easton, Dr. Hicks, and Dr. Rahman. Dr. Woodley and the Charleston Lab, thank you so much for helping me get through this. Dr. Kira McCartney, my dive buddy, all of my other divers that helped me out. The San Antonio Zoo, Charles Doolby from the California Academy of Science, which is the only other person that I found that grew mesophotic corals anywhere. Thank you.
This we had at the beginning, we have time for one question. Right?
I have kind of a question for your intro. So since these corals don't have losing belly, do you think that with climate change they'll kind of start to take over some of the areas that sclerotinia is over?
That's a good question. Maybe. I was looking, when I was reading through all my papers, they were kind of looking at it as a plan B for maybe sclerotinia might be a little further down the water column, but yeah, that's a good question. I don't know about their light because there has been some mesophotic corals or antipatharians that are found, in shallower waters, but they do get pigmented during the light. So that would be the only. But that's another thing we want to test in an aquarium. Maybe have different lights to see how they do. Because for this aquaculture, I did have a plastic mesh over the tank, just to make sure. I didn't want to. It was the first time, so thank you. Yep.
Thank you.